In this assessment, we're asked to predict the product of the cyclopropanation reaction on screen. Now notice here we're going to use two equivalents of the so-called Simmons-Smith reagent, and good news, we have two alkenes present in our reactant. Now you might look and say, well, what about the alkenes in this six-membered ring? That's benzene. Benzene rings are pretty unreactive. We'll see why in a later chapter, but we'll ignore those for now. The benzene ring is a very stable, unreactive ring. It's not going to react with the Simmons-Smith. Only the alkenes that are attached will react. Now, I always like to show the mechanism of these reactions. So the Simmons-Smith reagent as a so-called carbenoid is going to act like both a nucleophile and an electrophile. And we're going to do a concerted reaction that we can illustrate like this, where the pi bond attacks the carbon, kicks out the iodide, and at the same time, the electrons in this carbon-zinc bond attack back. We can do the same thing down here. Attack the carbon, kick out iodide, the electrons in the carbon-zinc bond add back. In both cases, we're going to make our cyclopropane so that the product that we'll draw, cyclopropane on the top, cyclopropane on the bottom, and don't forget the other group that came along for the ride, the T-butyl ether. And so this is the product we would expect in this reaction. Now, if we want to number carbons to make sure we have this right, we'll call this carbon 1. Let me grab a new marker. We'll call this carbon 1, this carbon 2, this 3, this 4. So we'll say that this is 1, this is 2, 3, 4. In each case, we added a new carbon. We'll call it 5 and 6. That would be 5, and that would be 6. So again, numbering carbons to make sure that our understanding of the chemistry is not ruined by dropping or adding an extra carbon atom.